Claudia, I'm just going to do a question that's in the workbook. So it's chapter 21 in the workbook, and it's question 12. So I'm just going to run through this one now, because it's kind of got everything in it. So it says a student carried out an experiment to measure the heat of neutralisation of hydrochloric acid with sodium hydroxide. And the question tells you that 50 centimetres cubed of a 1 molar hydrochloric acid solution was reacted with 50 centimetres cubed of a 1 molar base solution. Now, the initial temperature. So at the start, the temperature was 14.3, and at the end, the temperature was 21.1. That means the temperature change from start to finish was 6.8 degrees. And it asks you, it tells you that the specific heat capacity of the solution is 4060 joules per kilogram per Kelvin. And you've got to find the heat of neutralisation. So calculate the heat of neutralisation. Now then, you're going to use a formula for this. The formula is that the amount of heat energy generated by mixing those two solutions is given by the equation mc theta, where m is the mass of the substance, the mass of the solution, given in kilograms. C is the specific heat capacity, which will always be given to you in the question, which in this case is this figure here, 4060. And theta is the temperature change, which in this particular case is the delta T here. Okay, so you're going to find the amount of heat energy generated when you mix those two solutions. So E is equal to. Okay, the other thing that you're told in the question is that the density of this resulting solution, when you mix the acid and base, the density is 1 gram per centimetre cubed. So when you mix this acid and base, you have 100 centimetres cubed. So that means the density of this resulting solution is mass over volume, and your volume for this particular experiment is 100 centimetres cubed. So the density is 1, it's equal to mass over 100 centimetres cubed, and when you cross multiply, that gives you a mass of 100. And of course, because the density was given in grams per centimetres cubed, that 100 is grams. And in order to put this 100 mass into the equation up here, you're going to have to change this to kilograms. So this is 0.1 kilograms. Right, so the amount of energy that when you mix this acid and base, the amount of heat energy generated then is 0.1 multiplied by 4060 multiplied by 6.8. And when you multiply those three numbers out, you get 2760.8. So that's in joules here, because the specific heat capacity was given in joules. So this is the amount of joules that was generated. Okay, now where did that energy come from? So it's the H pluses you're interested in, not the OH minuses, always the acid. So how many moles of HCl generated 2760.8 joules? So remember, the number of moles is volume by molarity, and the volume has to be in litres. So the volume is 50 centimetres cubed, so that's going to be 50 over 1,000, bringing that to litres, multiplied by a molarity of 1, given in the question. And when you multiply that out, you end up with 0.05 moles. So what's that telling me then? So I now know that 0.05 moles of H pluses, because it's the H pluses that are going to do the neutralising, 0.05 moles of H plus will generate 2760.8 joules of energy. Question asks me for the heat of neutralisation. Now, the heat of neutralisation is the heat generated when 1 mole, and this is a definition that you have to learn, the heat generated when 1 mole of H plus ions from an acid is neutralized by 1 mole of OH minus ions from a base. So that's your formal definition. So that's an important definition. Heat of neutralization. Okay, so that means if I want to find the heat of neutralization, I have to find out how much energy is generated from 1 mole. So 0.05 moles gives me that much. So 1 mole of H plus ions will give me 2760.8 divided by 0.05, and I end up with 55,216, and of course that's joules. And then to turn it into kilojoules to make it, because it's normally measured in kilojoules, that's going to divide it by 1,000, 55.216 kilojoules per mole.